All right, ladies and gentlemen, at this point in time, I'm going to need your attention. We're going to start things up officially now. Sitting in front of you, you should have a pile of papers in the portfolio order that we just said. I'm going to come by and stamp them. The reason why I got them in a nice little pile is so I can be minimally distracting. I can just come over, creep over your shoulder, grab it, stamp, 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 and then slowly creep away while we're doing some relatively cool stuff up here. So we've got two different demonstrations going for you today. We've got this thing with clay. We also have something that relates to the activity that you did yesterday. So what we're going to need you to do quickly, I'm going to actually set this over here. Otherwise, you remember that whole thing about the size of that one kid's head? Yep. Okay, cool. No, you can leave right there. What we're going to do is we're going to take a look at the corner of this table. Hey, how you doing? We're going to take a look at the corner of this table right here and the objects floating in there. These are the objects that you used yesterday. You actually had 4 of these objects at your table. You computed densities, and then you predicted how they would float in water. Now, all of you got to different spots. Some kids have computed densities only. Some kids predicted where they would float, and some kids actually got a chance to drop these things in water. What we need to do at this point is take a look at that sheet you were working on yesterday, which should be on the top of your pile, and flip it over so that you're looking at the pictures of the cups. So the pictures of the cups, right? Those are the pictures with your predictions and the actual results if you made it that far. What we need to do is take a quick peek over here, and you're going to actually see the materials that you had. Now, you had 4 materials, okay? And you may have had some combination of these. All of you had a metal. You either had this metal or that metal there, okay? And you drop those in water. Both of them have densities greater than 1, so they sink. Then you guys had one of these things right here. You either have kind of a clearish plastic or one that looks a little bit grayish black. I know there was a fight as to whether or not that was gray or black yesterday. But you also got one of these, and these things are also sinkers. Then you got 2 out of these 3 items right here. So you guys got 2 out of these 3 items right here. All of you have 2 pieces of wood, and one magical group in here got this weird white thing, which I think might be you guys, where you're the only person in your group still. So we're going to hide this one right now, because she's in a little bit of a special spot. All of you have these 2 pieces of wood, and all of you found that their densities were less than 1. So when you drop them in water, they should both float. So what I'm going to do is I'm going to pop these 2 things here for you. Look right in the front of the tank, and you're going to notice that they are both floating. I'm going to turn just a little bit like that. You can kind of see, kind of not. If you need to stand up, that's fine. So take a look at those 2 pieces of wood, the 2 samples of wood that you've had. Please notice that they are floating differently than one another. As I look at your final results, it should be obvious that they are floating differently than one another because they're different types of wood. In fact, one of them is oak, the other is pine. Some of you might know some stuff about wood already, which does make it a little bit easier for you. All right, so I'm going to ask you a question about your observations that you see right here, and then we'll kind of kick it up a notch to the next level, which is something you may or may not know. What do you know about these 2 densities here and how they compare to each other? Just by looking at the way that they're behaving in water. I'll wait till I have several hands in the air before I move forward. If you need a moment to think about it, that's fine. But again, I'm going to say, what do you know about these 2 densities and how they compare to each other? They're definitely floating differently. So they definitely have something in common, but they definitely have something that's different about them. So what can you tell me? Yeah, what are you thinking? Go ahead.
The right one weighs more than 1 gram, the left one weighs 1 gram.
We're getting there, okay? We're getting there, but we got some problems with what you said. One is we're talking about weight. Weight doesn't matter, okay? If something light doesn't make it float, I'm going to allude to what you're going to talk about. For example, are cruise ships heavy? Yes. Here, can you bring this cruise ship over? Sure. No, cruise ships are heavy, but cruise ships, most of the time, float. So we can't use heavy and light. Do you see what I'm saying? Okay, because just because something is heavy doesn't mean it's going to float. I'm sorry, it doesn't mean it's going to sink. For example, a stone is relatively heavy, but relatively light, but it will sink. So we can't use heavy and light. What can we say about their densities, how they compare to one another? Okay, but thanks for getting that conversation started. Yeah, what are you thinking?
The block in the left has more density than the one on the right.
Okay, so this one right here, I'm going to go like this, ding, 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 ding. This one right here is definitely more dense than that one right there. What do their densities have in common, though? I'm sorry, are you okay with that? You gave me an angry face. Are we good with this? This one is definitely more dense than that. Are we good? Okay, are you sure?
Yeah.
Okay, because your eyebrows were telling me something else. No? Okay. So what else, what do we know about their densities? You're going to say something else? Go ahead.
The one on the right is less than the one on the left. Yeah, what he said.
Okay, what he said, but the opposite way. Okay, so the one on the right is less than the density of the one on the left. Okay, perfect. What do the densities have in common? They are both what? We know that one's greater and one's lesser. But what do they have in common? What do they have in common? Yeah, sorry.
They're both lighter than water.
Yeah, they're both, we don't want to use lighter, but their densities are both less than water. All right, absolutely perfect. Now we'll show you something cool. What is, for pine, what is the smallest density you computed? Can you tell me? Look at the front side. Take a look at it. Yeah, take a look at it. If you could get your hands up in the air, that'd be good. Okay, we got a 0.5, that one I heard. Okay, what else do we have over here? What do you guys get?
Same with 0.5.
0.5 roughly? What is it, 0.5? All right, let's check this out then. This is your 0.5. This is where it gets real. This is actually super cool, and there's very little math involved. This is just one of those things where you'd be like, oh, that's awesome. Check this out. This is right around 0.5, okay? In fact, it's 0.5, or when I did it, I found it to be 0.6, but I might have had a little bit more dense piece of wood. There could have been like some knots or grains in it that could make it a little bit more dense, okay? But let's take a look at that. The density of this one is actually 0.6. This is the one that I did. About how much of that water, I'm sorry, how much of that block is below the water, would you say? If you had to estimate, about how much? About half? Yeah, about half. Maybe even a little bit more than half. What do you think? A little bit more? What? About 0.6 of it. No way. Is it really that easy? Ladies and gentlemen, this has a density of 0.6. And when you put it in water, 0.6 or 6/10 of it is under the surface. How much of it is above the surface? 4/10. That's a split 60-40. Can you tell just by looking at it?
Yeah.
It's split 60-40. When you put yours in water, if you found it to be 0.5, then you're probably half above and half below, if you were to take a look at it. So how would it float if it had a density of like 0.8? How would it float if it had a density of 0.8? How much below, how much above, would you say? 0.8. Remember, that would be more dense. So we're going down. How much below, how much above? What are you thinking? Jimmy, what are you thinking?
80.8 will be under, and 20%, 1.2 will be above.
Yeah, you notice you're struggling with the, well, it's 0.8 or like 80%. A percentage is a decimal. 0.8 is 80%. Okay, you might remember that because you just slide the decimal two places. That's why you're using those two terms interchangeably, because they are the same thing. Yeah, you'd be split 80-20. Now take a look at this thing here. Look at that. That's your heavier piece of wood. I'm sorry, now I'm using the word heavier. This is the, I just got busted right there. This right here is your more dense piece of wood. Okay? What do you think the density would be of that by looking at it? Just take a peek. Look at the wood. You don't even need to look at your math. What would you say? Take a look at that thing right there. Just put it right there like that. If you had to estimate it by looking at the way it's floating. Yeah, what are you thinking?
0.8.
Yeah, I think 0.8. Maybe even more, maybe even some of you are going to say 0.9, possibly. Did you do this one? What did it end up being? 0.6. That's probably the other piece of wood. Do you have one that has a smaller density than that? This might not be your cube, too.
2.9.
2.9. Let me take a look at your data here. At 0.6. There it is. So of course, it's the one all the way at the end. This one right here is 0.9. Now, 0.9, it works out to about 0.95. This is going to be a low floater, okay? This is going to be a super low floater. It's 0. That means like 0.9 under and just 0.1 above. Let's take a look. That's a low floater. You can check that out. That's about as low as it gets, okay? You take something like a beach ball, put it on the water. And beach ball barely goes under. Does it land in your pool like this? The wind blows and it goes across your pool like that, okay? That'd be something. What would the density of like a beach ball be then? What do you think of the density of a beach ball would be? You gotta look at how much is above and how much is below. What would you think? What?
3.8.
Yeah, maybe even less than that. Maybe there's not even a tenth of it. Yeah, maybe it's like 0.05, okay? Or maybe 0.01. It barely goes under at all. That's cool stuff. Okay, styrofoam like floats really, really high too. It's good stuff. All right, what we're going to do is we're going to take a look at something a little bit more complex than this. This just takes a look at density of substances and whether or not they sink or float. But we did bring up something interesting earlier about the cruise ship. Cruise ships are made not of styrofoam or beach balls. Cruise ships are made of steel. Steel, float, or sink? Sink. We got a problem. So that's what we're going to be talking about right now. So you guys can go ahead and get started on your journal entry. I'll switch your screen over for you. Should be good to go.